Welcome back, and in this lesson I want to continue the theme of VPC networking in AWS by covering VPC subnets. Now, subnets are what services run from inside VPCs, and they're how you add structure, functionality, and resilience to VPCs, so they're an important thing to get right, both for production deployments and to do well in the exam. So let's not waste time, let's jump in and get started. In this lesson, we'll be starting off with this architecture. This is exactly how we left off at the end of the previous lesson, a framework VPC, a skeleton. What we'll be doing is creating an internal structure using subnets. We'll be turning this into this. Now, if you compare this diagram to the one that I've linked previously, you might notice that the web tier subnets on the right are blue on this diagram instead of green on the diagram that I've previously linked. Now, with AWS diagrams, blue means private subnets and green means public subnets. Subnets inside a VPC start off entirely private, and they take some configuration to make them public. So at this point, the subnets which will be created on the right, so the web tier, they'll be created as private subnets, and in the following lessons, we'll change that together. So for now, this diagram showing them as private subnets is correct. So what exactly is a subnet? It's an AZ resilient feature of a VPC, a subnetwork of the VPC, a part of the VPC that's inside a specific availability zone. It's created within one availability zone and it can never be changed. Because it runs inside of an availability zone, if that availability zone fails, then the subnet itself fails, and so do any services that are only hosted in that one subnet. And as AWS solutions architects, when we design highly available architectures, we're trying to put different components of our system into different availability zones to make sure that if one fails, our entire system doesn't fail. And the way that we do that is to put these components of our infrastructure into different subnets, each of which are located in a specific availability zone. The relationship between subnets and availability zones is that one subnet is created in a specific availability zone in that region. It can never be changed, and a subnet can never be in multiple availability zones. That's an important one to remember for the exam. One subnet is in one availability zone. A subnet can never be in more than one availability zone. Logically though, one availability zone can have 0 or lots of subnets. So one subnet is in one availability zone, but one availability zone can have many subnets. Now the subnet by default uses IP version 4 networking, and it's allocated an IP version 4 CIDR. And this CIDR is a subset of the VPC CIDR block. It has to be within the range that's allocated to the VPC. What's more, the CIDR that a subnet uses cannot overlap with any other subnets in that VPC. They have to be non-overlapping. That's another topic which tends to come up all the time in the exam. Now, a subnet can optionally be allocated an IP version 6 CIDR block as long as the VPC also is enabled for IP version 6. The range that's allocated to individual subnets is a /64 range, and that /64 range is a subset of that /56 VPC. So a /56 IP version 6 range has enough space for 256 /64 ranges that each subnet can use. Now, subnets inside a VPC can, by default, communicate with other subnets in that same VPC. The isolation of a VPC is at the perimeter of the VPC. Internally, there is free communication between subnets by default. Now, we've spoken in previous lessons about sizing. So sizes of networks are based on the prefix. For example, a /24 network allows values from 0 to 255 in the 4th octet. Now that's a possible 256 possible IPs. But inside a subnet, you don't get to use them all. Some IPs inside every VPC subnet are reserved. So let's look at those next. There are 5 IP addresses within every VPC subnet that you can't use. So whatever the size of the subnet, the usable IPs are 5 less than you would expect. Let's assume, for example, that the subnet we're talking about is 10.16.16.0/20. So this has a range of 10.16.16.0 to 10.16.31.255. The first address which is unusable is the network address. The first address of any subnet is the one that represents the network, the starting address of the network, and it can't be used. This isn't specific to AWS, it's the case for any other IP networks as well. Nothing uses the first address on a network. Next is what's known as the network plus one address, the first IP after the network address. And in AWS, this is used by the VPC router, the logical network device which moves data between subnets and in and out of the VPC if it's configured to allow that. The VPC router has a network interface in every subnet, and it uses this network plus one address. Next is another AWS specific IP address which can't be used, called the network plus two address. In a VPC, the second usable address of the VPC range is used for DNS. And AWS reserve the network plus two address in every subnet. So I've put DNS and an asterisk here because I refer to this reservation as the DNS reservation, but strictly speaking, it's the second address in a VPC which is used for DNS. So that's the VPC range plus two. But AWS do reserve the network plus two address in every single subnet, and so you need to be aware of that. And there's one more AWS specific address that you can't use, and you guessed it, it's the network plus three address. This doesn't have a use yet, it's reserved for future requirements, and this is the network plus three, in this example 10.16.16.3. And then lastly, the final IP address that can't be used in every VPC subnet is the network broadcast address. Broadcasts are not supported inside a VPC, but the last IP address in every subnet is reserved regardless, so you cannot use this last address. So this makes a total of 5 IP addresses in every subnet that you can't use, 3 AWS specific ones, and then the network and broadcast addresses. So if a subnet should have 16 IPs, it actually has 11 usable IPs. So keep this in mind, especially when you're creating smaller VPCs and subnets, because this can quickly eat up IP addresses, especially if you use small VPCs with lots of subnets. Now, a VPC has a configuration object applied to it called a DHCP option set. DHCP stands for Dynamic Host Configuration Protocol. It's how computing devices receive IP addresses automatically. Now, there's one DHCP option set applied to a VPC at one time, and this configuration flows through to subnets. It controls things like DNS servers, NTP servers, NetBIOS servers, and a few other things. If you've ever managed a DHCP server, this will be familiar. So for every VPC, there's a DHCP option set that's linked to it, and that can be changed. You can create option sets, but you cannot edit them. So keep in mind, if you want to change the settings, you need to create a new one and then change the VPC allocation to this new one. On every subnet, you can also define 2 important IP allocation options. The first option controls if resources in a subnet are allocated a public IP version 4 address in addition to their private subnet address automatically. Now, I'm going to be covering this in the lesson on routing and internet gateway because there's some additional theory that you need to understand about public IP version 4 addresses, but this is one of the steps that you need to do to make a subnet public. So it's on a per subnet basis that you can set auto-assign public IP version 4 addresses. Another related option defined at a subnet level is whether resources deployed into that subnet are also given an IP version 6 address, and logically for that to work, the subnet has to have an allocation, as does the VPC. But both of these options are defined at a subnet level and flow on to any resources inside that subnet. Okay, so now it's time for a demo. That's all the theory that I wanted to cover in this VPC subnet lesson. So in the demo lesson, we're going to implement the structure inside the VPC together. We're essentially going to change this skeleton VPC into a multi-tier VPC that's configured with all of these subnets. Now, it is going to be a fairly detailed demo lesson. You're going to have to create all of these 12 subnets manually one by one. And out of all of the lessons, the detail really matters on this one. We need to make sure that you configure this exactly as required so you don't have any issues in future. Now, if you do make any mistakes, I'm going to make sure that I supply a CloudFormation template with the next lesson that allows you to configure this in future automatically. But the first time that you do this lesson, I do want you to do it manually because you need to get used to the process of creating subnets. So controlling what the IP ranges are, being able to select which availability zone they go in, and knowing how to assign IP version 6 ranges to those subnets. So it is worthwhile investing the time to create each of these 12 subnets manually. And that's what we're going to do in the next demo lesson. But at this point, go ahead and complete this lesson, and then when you've got the time, I'll see you in the next demo lesson where we'll complete the configuration of this VPC by creating the subnets.